All right, number 22 says to sketch the function. This is when you really can't sketch. It's not a parent function we know, so you need your calculator to do that. So go to your graphing calculator, type in y equals square root of 2x squared minus x. Make sure all of that is under the square root sign. Once you get it in there, first of all, make sure all your plots are off. So if you have something where you see that that's highlighted, just so you don't get an error message, arrow up and hit enter and make sure that you shut the plot off. All right, then you need to worry about your window. You can go to window and change your window to whatever you need it to be. I would just go to zoom and go down to zoom 6. That's just the standard window. That's the best place to start. It goes from -10 to 10 for both x and y. So then I see it kind of looks like an absolute value. It comes down here and then it goes back up. So that's kind of what the graph looks like, I would say, but I want to make sure nothing with the domain is going on crazy there. So what I'm going to do is I'm going to zoom in. I'm going to hit zoom and number 2 in, and wherever my cursor is, which it's at like 0, 0, that's probably a good place. I want to know what's going on right in there. So having it at 0, 0 is a good place. So I'm going to hit enter. And now I see it looks like there's something going on right here. It doesn't come down to a point like the absolute value. Something looks like it's missing. So when I graph it, all I really need is a sketch of the graph. So you can make a sketch and you can say, all right, it kind of looks like it comes down this way, and then it looks like it takes off again that way. Whoops. And it looks like it's going on forever. We could zoom out if you want to make sure it looks like it goes on forever. But I would guess, in fact, let's do that. Let me go zoom out, and we'll zoom out a few times just to make sure it looks like it's going forever. Or what we could actually do is let's go from -100 to 100, and let's go y is negative. Y so it wouldn't have to be negative. I actually could start at 0. Let's start at 0 and go to 100, just to make sure it goes on forever. And yep, it does. It comes down and then it goes back up. So you can definitely like check to see if it looks like it's going to go on forever. But zoom standard, let's get back to our regular window. So I see that there's something going on here. So if I want to see specifically, the best place to do that is your table. So first of all, go second window, second table set. Make sure you probably start at 0 because that's the place I want to know what's going on. And make your delta table like 0.1. That way it'll check 0, 0.1, 0.2, 0.3, and I can see what's happening. So now if I go to table, I notice that everything where it's negative, which makes sense, all of this is graphed, and it's getting bigger and bigger as I go -0.6, -1.7, -2. These numbers are getting bigger. So now if I go back down, what's happening? Once I get to 0, I have 0, 0, so that point is there, but then there's an error message. So there's an error between 0 and all of a sudden when I get back to 1/2, it goes back to 0 again. So I have the ordered pair 1/2, 0, and 0, 0. Everything in between 0 and 1/2 is undefined because I get that error message. So again, to get that, I just went to table set. Make sure you start at 0, and this is a decimal point, and go second graph, second table. Anywhere where you see an error, that means it's undefined. Okay, so there's a picture of the graph. I labeled these points so I kind of know exactly where they're at. It says identify the domain, so the domain of the x value. So think about going across this way. Everything is graph going across except for that one empty space right there. So the easiest way to write the domain would be to say it's going to go from -infinity to 0. So that's this piece right here. The x's go from -infinity on the left all the way to 0. It stops at 0, and then it starts again at -1/2, and it goes to the right forever, or +1/2, sorry. So then it's, I put U for union. You don't have to put that. But again, bracket 1/2 to infinity. So it starts at -infinity on the left, it goes to 0, and then it goes from 1/2 to infinity. So domain, you're looking this way. If you want to write it using like inequality signs, this piece would be x is less than or equal to 0, or the other piece would be x is greater than or equal to 1/2. I really don't care which way you write it. It's up to you. But that's a domain. You're thinking of the x's. For the y's, the range, you're thinking of the y's. So think about what numbers are graphed going up and down. Nothing is graphed down here. It starts at 0, and then it's going to go up forever. Both of these have arrows up, so it'll go up forever. So it starts at 0, and it goes to infinity. Or again, if you want to write it with inequality signs, you would say y, because now you're dealing with the y's, are greater than or equal to 0. Now you're looking at lowest point is 0, and it's going to go up forever. Okay, so that's the range. All right. Then if you look on the next page, I'll get 23 and 24 done. It's just making sure you can subtract. So I'm going to take f of x minus g of x. As long as these are the same, you can add or subtract them. So 5 of these minus a negative 4 of those. We got to be careful. It's 5 of those terms minus a negative 4 of those terms. So it's like adding 4 of those. I get 9 of those terms. Okay, so just be careful when you subtract. And then it asks for the domain. Here's what you need to know about domain. Is if this is an even root, which it is, it's a square root, what's underneath here for domain has to be greater than or equal to 0. And then just solve that. To solve it, I add 1 to both sides, and I get x has to be greater than or equal to 1. Because you could think about the graph. This is going to move 1 to the right, and a square root function, remember, normally looks like this. So if I move it 1 to the right, it makes sense. I'm going to have all x's greater than or equal to 1. But you don't really even have to graph it. Just if it's an even root, square root, 4th root, 6th root, what's underneath there, just set it greater than or equal to 0 and solve that inequality. That's your domain. So this is my answer of f minus g. This is my domain. All right, so 24. 24, again, we're subtracting. We have negative 20 of these terms minus 6 of those same terms. So if I have negative 20 minus 6, I'm going to have negative 26 of those terms. All right, so that's my answer to that. The next piece is what's the domain? The domain of anything that has an odd root, because remember what the graph looks like, the domain is going to always be all reals, because now I can put in cubed roots of negatives and it's okay. So anytime that this is an odd root and it asks you for the domain, you're just going to say all reals. You can put an R for all reals. You can say all numbers, but it is everything. The only thing that will have a domain problem will be if you have the square root or an even root. Then what's under the square root, 4th root, set it greater than or equal to 0 and solve that inequality. So there will be one like each of those on the test tomorrow.